Hello and welcome to our discussion of thermometry. And we're going to start out by talking about the birth of thermometers and the different kinds of early thermometers, and then we'll work our way into temperature scales. So first off, exactly what is temperature? And temperature, of course, is a quantity that's measured by a thermometer. That's what it says in the glossary of meteorology. But in effect, what we're trying to do is trying to measure kind of the average molecular motion of the molecules, of course, whether it be solids or liquids or a gas. Gases we can visualize very easily, molecules bouncing around, bouncing off of thermometers, but even liquids and solids, the molecules vibrate, and we're trying to measure the vibration of those. So with gases, of course, the molecules are zipping around, and what temperature does, it tries to average or tries to measure or tries to put a number on the translational motion. In other words, the kinetic energy of those molecules. So a lot of times heat and temperature get confused. So temperature, just want to state one more time that it's the measure of the molecular motion, whereas when we talk about heat, it's the actual movement of energy from one place to another. Now let's talk about temperature scales. And there are quite a few different temperature scales. We'll start out first by discussing the early thermometers, and then after that we'll get into the early temperature scales. So early thermometers were called thermoscopes. Basically, what a thermoscope did was it measured the temperature of a substance by the change in a fluid, whether it goes up or down in a tube. So here's an example of an early thermoscope. The fluid in the tube actually went up or down based upon the air density. Now the problem with this is that it also acted as a barometer, and of course early thermoscopes really didn't have temperature scales, or at least standard temperature scales. The first known publication of a thermoscope, or description of a thermoscope, was Giuseppe Bianchi. But after that, Galileo is probably the most famous for thermoscopes, and he made one that's still popular today. But there are others also that were famous thermoscope makers. The Galileo thermoscope works based upon principle that the density of water varied with temperature. So if you had glass that's you had little glass bubbles that encased different fluids that had different weights, then they rose and sank within the tube of water based upon the density of the water. So this actually wasn't invented by Galileo, but it was actually invented by Galileo's students. The first thermoscopes with a scale came out about 1611. There are various inventors, and there are arbitrary scales. They were no real fixed scales. They started sealing up thermoscopes in about 1654. That's when we can call it a thermometer from that point on. However, even at that point, there were no standard scales. And then finally, about 1714, in Holland, there was a German physicist named Gabriel Daniel Fahrenheit, and he came up with a standard scale with references, and the reference was at 100 degrees you had body temperature, and at 0 you had the temperature of an ice, water, and salt mixture. Other people proposed temperature scales. René-Antoine Reaumur was a French scientist, and he proposed a scale at which point you have 0 for the melting point of ice and 80 would be the boiling point of water. And then Anders Celcius also came up with a similar scale where 0 was actually the boiling point and 100 was the melting point. Now he used this with his mercury in glass thermometer, which was kind of a new thing back then in 1742. The thing that's interesting is that it appears initially that the scale was reversed, where 0 was the boiling point and 100 was the melting point. In 1745, the scales were reversed to what we have now, where 0 is the melting point and 100 is the boiling point. And then, of course, Lord Kelvin, or William Thomson, famous English physicist, came up with the concept of absolute zero, absolute temperature scale. He proposed that in 1848, and he designated 0 to be absolute zero, but he used the temperature intervals of the Celcius scale. So it was just offset by 273 Kelvin, or 73 degrees. And then finally, William Rankine came up with a temperature scale similar to Kelvin, except that instead of using the intervals for Celsius, he used Fahrenheit and defined 0 as absolute 0. And then with the Fahrenheit scale similar to what Fahrenheit came up with. That's all I have for you for this lecture, and we'll talk about absolute 0 in the next one.